Hello everyone, I'm Luca Mozzoni, a student of the Master's degree in Computer Science at the University of Camerino, and in this video we'll present you Rainfall, which is a data flow programming framework integrating mixed methods analysis. Rainfall enables the rapid prototyping of analysis pipelines through a user-friendly interface in a web application. It is open source and designed to ease the implementation and the execution of a data analysis pipeline. Let's create a new pipeline by selecting nodes from the left drawer. Here we can see all the available nodes divided either by type or by library. In this case, we will use the PM4Py Python library, which is used for process mining analysis. We will read an XCS file and print out a BPMN model. In the middle, we will use the inductive miner algorithm in order to discover the process model. So now that we have all the nodes, we can connect them together. And by double-clicking on them, we can further configure them. In this case, we will need to specify the file ID that the XCS loader will read. So we go to the import-export page, copy the file ID that we previously uploaded, and paste it in the node configuration form. Since the BPMN writer will write a BPMN model, we will need to specify the destination folder for this node. So we will copy the folder ID and paste it in the node configuration form as well. So now our pipeline is all set, and we could export it as a UI file or a script file that we can upload later in the canvas. If we now press the play button, the pipeline requirements will be displayed, and when we click OK, the pipeline will finally be launched. We can now monitor the pipeline in the executions page. So now that the pipeline is done running, we can see on the right all the produced logs. And if we go to the import-export page, we can see the produced BPMN model. Let's now create a custom node. A custom node will execute code defined by the user in the custom node editor, which supports the Python programming language. The custom node editor supports all the features that a common IDE supports, such as syntax highlighting and autocompletion. In order for the custom node to be defined correctly, we will need to define a function that receives at least two input variables, which we'll use to specify the input and output pins of the node. Other parameters can be given to the function as well and will be treated as normal variables. In the body of the function, we will then need to define how the data will be handled by the node itself. And to do that, we can also make use of other Python libraries, such as SciPy, which is the one used for this specific custom node. Finally, we just have to give a meaningful name to the newly created custom node so that we can recognize it among the other nodes that we already have in the canvas page. We will now use the custom node we just created in a machine learning pipeline. In this case, we will use the K-Medoids clusterer node to run the K-Medoids algorithm on the iris dataset, which is often used to showcase how an algorithm works. The custom node will pre-compute the distance matrix in the dataset and pass it along to the K-Medoids node. We will then use two output nodes to save the results of the pipeline in a local folder in Rainfall. As we did for the previous example, we can go to the executions page in order to monitor the pipeline. And once it is done, we can go to the import-export page to check out the results produced by it. Rainfall also offers some major features that improve the overall pipeline management. For example, it is possible to upload the UI state of a previously executed pipeline from the executions page, so that it can be further configured or saved in a repository. Repositories allow users to save pipelines and use them in the future or share them among team members and organizations. In this way, users can keep track of a pipeline changes over time. In the video description, you can find more information about the tool and the ProsLab research group. Thanks for the attention and see you next time.